Welcome again. Till now we have seen insertion at beginning, then insertion at end. Now how to do insertion in middle. So before that, what exactly we have to do in insertion, that will refresh. We have seen for any insertion case you have to adjust two pointers. For any insertion in SLL, singly linked list, two pointers are adjusted. Then next, always whenever you insert, then you should know predecessor node's address. Predecessor node's address should be known. Then always set link field of new node first. What is this that I'll tell you. Take a sample link list. Assume that I have some 4 nodes in that, some information fields. This is first. I want to insert in middle. Suppose I want to insert 7, after this 5. So concept is same. In insertion you have to create one new node by malloc, set information field. Now here, when you want to insert this node, after this node means this node will be in between 5 and 8, right? So 2 pointers, which 2 pointers we have to adjust? See, this should be adjusted and this field should be adjusted. So this should point to this node. After insertion, what will happen? I'll give dotted lines and this should point to this node. This should happen. Means this field I should give this node's address. This field I should give this node's address. Now for adjusting, always set, see, these 2 pointers we have to adjust. This one, this one. Always for any case 2 pointers will be adjusted. Now first case we have seen. Second case, predecessor node's address is required. Why we are saying predecessor node's address is required? Because see now, I want to set news link field suppose. What way I can write? How to access this field? News link field, right? I want to change. I want to give this node's address to here because this should point, after insertion this will point to this node. So this link field should contain this node's address. Where is this node's address? In this link field. Can you access link field of this node? No, you cannot, because you should have address of the node to access any field, either info or link. This node's address is not there. So always whenever you are setting or whenever you are inserting, you should know predecessor node's address, then only you can access this link field. So assume now I have this address is in X. So need of predecessor node we have seen. Now if you have address of predecessor node in X, now this field I want to set with this node's address. This node's address is in this link field. This node's address currently is in this link field. So this field, how to access this field is given to this field. How to access this field? New access link field. Access link field. That's it. this link is adjusted. Always set link field of new node first. What will happen if you do opposite, we'll see. Now this field we have to set. How to access this field? Access link field is given. This access link field, this node's address, because this should point here. What is this node's address? This node's address is in new, so new is given. That's it. This will be set now. This link won't be there. Now see, link adjustment we have done. 2 pointers we have adjusted and we have inserted node in a middle. Correct? This is general case. As I said, always set link field of new node first. Why we are saying that, I'll tell you. If I set first, suppose earlier linked list, if I set first link field of X first, this first, X link, where it should point to new node. So new is given to X link. Assume first you have done this. So you have set this pointer now. Now which pointer you have to set? This. Which address we want? This node's address. Do we have this node's address anywhere? No. We don't have anywhere, because and in this way we are losing the entire this list. We may not find that, because you cannot adjust this link field because this node's address is not there. So if you want, if suppose in the earlier statement we have written the next statement like this, news link is given access link. Earlier, if you write this way, what will happen? See, access link is set first, it is pointing to new node. Now access link field, this field, what is this field? This node's address, right? Now this node's address is given again to new link. This is new node, news link. So this will be a pictorial representation of the statement if you write this way, and you are losing entire linked list. And moreover, if you start printing this linked list after adjusting this way, some way, it will be an infinite loop here. It will print 2, it will print 5, it will print 7. When you go for next node is this 7, next node is 7, next node is 7, and it will not terminate. So always keep this in mind, links should be adjusted correctly. If anyway I want to first set access link field, then what way you have to do? See, this is pointed by new, this is X. First you store the address of this next node, access next, in temp. This is not a correct way actually, but if you want to set that, first save address of this node. How to save address of this node? In temp is given access link field. You can do this. X link is pointing currently to this node. This node's address we have given in temp, so temp is pointing to this node. Then new is given to X link. This X link you are setting, so this pointer you are changing, this you have changed. Now after this, news link you have to set. News link should point to this node now. Now earlier this node's address we have saved in temp, so temp is given. So this is other way. So what is current status and all of link, that you should know while writing the statements, right? Now after this we will see a special case, that is insertion in order. How to insert insertion in order. Order means if we want to insert suppose 9 should be inserted in this list in order, means after 8 that node should be. If I want to insert 20 in this list, 20 should be after this node. I'll take as example and I'll terminate this. This is first node. Assume I want to insert a node in order. So what will be different cases that I'll give you. Wherever, suppose this is 2. Assume that I want to insert in this linked list one element in order. So where will be the position of 1? Obviously it will be before this first node. So this only is forming a special case in this insertion order. So I am saying insertion in order. In insertion in order, first special case will be, suppose element you are giving, element to be inserted is 1 in this case. So this special case says if element to be inserted is less than info field of first node itself. So how to access first info field? If this is the case, then insert at beginning. Whatever links we have to adjust, that you have to adjust. If this is not the case, suppose element to be inserted is, suppose you want to insert 7 in this list. Now, where is the position of 7 in this linked list in order? After 5, right? Now, how to create logic for this? Now, I said already, whenever you are inserting a node, see, the steps are same. New node is created. This is new. Information field is set. Now, what you should know always, predecessor node's address. Where you are inserting this node in between this and this. What will be predecessor for 7? Definitely this is 5. So you should have this node's address. What is this node's address? See, though we say first link has this node's address, but we cannot, there may be some hundreds of nodes before this. So how to get this predecessor node's address? That we'll see. There are two ways. One simple way I'll take first. One simple way. Then we'll see the other way. See, when I want this, whenever you want some address of some node, you require traversing. Traversing means visiting each node by comparing something, and we have to stop somewhere. So when temp is here, temp you are taking as temporary variable for traversing. Suppose whenever it comes, for this case, it should stop here. Suppose you want to insert 9. So where temp should stop? Because this forms predecessor node, temp should stop here somewhere. Means I should get some predecessor node's address, right? Now what? See, this is rough work I am doing, yet we have not coming to conclusion that this is logic. So first is given, temp is set. Now if I say while we are moving until, suppose I get the element in information field greater than this. When it is less, when element to be inserted is greater, suppose 7 I want to insert, 7 is greater than this, so I have to move. 7 is greater than this, I have to move. But now what is happening here? If greater we are moving, suppose I'll give when temp info field is less than element to be inserted. If this is the case, I want to move temp. Suppose what will happen? Temp's link field. What will happen? See, temps info 2, element 7, less move. Temp will point here. Again it will go. Now temp is pointing to this node. Temp's info is 5. 5 less than element? Yes. Move temp. Temp is moved. Temp will point now to this node. Now, what is temp's info? 8. 8 less than 7? No. This condition is false. It will come out. But what we are getting? We are getting this node's address. Do we want this node's address? No. We want this node's address. We want this node's address, right? So, what is solution for that? See, if whenever I am moving this temp is here, I'll take another temporary pointer, predecessor. Predecessor will be null. Whenever there is requirement of moving temp, move predecessor also to point to its temp's predecessor. Predecessor will be moved, temp will be moved. Now temp will be here, predecessor will be here. This logic works in that case. What I am doing, see. This is the first way by taking two temporary variables. This logic is used most of the time in this single linked list as well as in trees. Whenever you write tree operations. So what I'll do, see. Temp I'll point to first, but predecessor initially it will be null. So what I am taking here, predecessor I am taking as null initially. Temp is pointing to first. This condition I want to maintain, but small change what I am doing, see here in this case. When there is a requirement of movement of temporary, before moving temp, I'll move predecessor here and then I'll move temp. So what will happen? First I'll move predecessor. Predecessor should point to current temp. This is given temp. Now what will happen by this statement? Pred will point here to this node because temp is given to pred. Temp points to same node, pred points to same node. Now you move temp. Temp is given temp's link field. Now what will happen? See, pred is pointing here now. Next steps, temp is moved. Temp is given temp's link. So temp will be moved. Temp will be here. Right? Pred is pointing here, temp is pointing here. Again it will go here. Temp's info is 5. Element to be inserted is 7. What will happen now? Is it true? Yes, it will go here. Temp is given to pred. Pred will point to this node now. This won't be there. By these statements, temp is moved. Temp will point here. Right? Then again it will go. Temp's info is 8. 8 less than 7? No. Means this condition is false, it will come out. Now tell me, where is predecessor node's address after which we have to insert? Now we are getting predecessor node's address in pred. Now when you have predecessor node's address, this loop is giving you predecessor node's address. Now set link fields. Always we have seen two links we have to adjust. One, first you adjust news link field. After this you adjust news link field first. News link field. What you are giving, this we are setting. This should point to this node. Now temp is pointing here. Either you can assign temp here because temp always will be pointing to the next node in this case. But instead use this pred for everything. What will happen? See, this field should point to this node. This node's address is in pred's link. So predecessor's link field you can give here. This field is set. This is pointing now to this. Now which field you have to set? This field we have to set. How to access this field? Predecessor is pointing to this node. Predecessor's link field we are changing. Predecessor's link field we are changing. That should be given. This should point to this node. This node's address is in new. So new is given to this. Now this pointer won't be there. It will be pointing after that this new node. That's it. This much is for locating predecessor node's address. And this is only joining link field. Now before this statement, you are creating new node by malloc. You are setting info field. Right? Then this comes in logic. So this is one way to find predecessor node's address whenever you are inserting in order. But whether this works for every other case also, let us try. Let us insert element 20 in this list. 20. Now I'll assume earlier linked list only. Earlier linked list. Now let us, as we want to insert 20. What will happen by this logic? Predecessor is null. Temp is pointing to first. Temp's info. Temp's info is 2. 2 less than 20. Yes. Predecessor points here. Temp is moved. Temp points here. Temp's info field 5, 20. True. Temp is given to predecessor. Predecessor points here. Then temp is moved. Temp points here. Again, temp's info 8. 8 is less than 20. Yes. Pred is moved. Pred will point here. And temp is moved. Temp will be here. Again, temp's info 15. 15 less than element to be inserted. Yes. True. It will come here. Temp is given to pred. So pred will point here. Now what happens? Temp's link is given to temp. What is temp's link? Null. So temp will have null value here after this. Right? Then again it goes here. Temp's info is compared where temp is pointing. It is not pointing to valid node. So if you write this way, and if you are trying to insert in order this 20, then this will happen. And always what will happen with this, you might have seen, if you run this under Ubuntu or Unix GCC compiler, there will be segmentation fault. Segmentation fault will come. Whenever segmentation fault comes, that means you are accessing something which is not existing. Temp pointing to null means node does not exist, and that's info field you are accessing in this case. Right? So segmentation fault will come. Now how to tackle this problem? So I have to change my logic now, because when temp becomes null, see, when temp is moved, when temp was here, temp is moved, temp will be null, and pred is pointing here, right? When it again goes here, it should not come again inside this. It should come out of loop. So what condition you have to add into this? Right? So here, when you are moving, when either temp is not equal to null and temp's info field is less than element. Now whether it works or not, we will see, right? Pred will be null temp. This information is, see, temp is not null. Temp is pointing initially to first. Temp is not null and that is less. So pred will be moved, temp will be moved. Again, temp is here. Temp is not null and info field is, both conditions are true. When both conditions are true, pred will be moved, temp will be moved. Again, temp will be is here. So here again both conditions are true, pred will be moved, temp will be moved. Then here temp is pointing here, temp is not null. Temp's info field is less than element, yes. Then what will happen? Pred will be moved, temp will be moved. This scenario will be there, right? Pred will be moved, temp will be null now after this statement. When it comes again here, now it will check whether temp is null. Yes, now temp is null, means it will come, this is false. When temp reaches at end after last node, that will be null and this condition becomes false. Whenever you are combining two expressions with logical AND, if first expression is false, then it will not evaluate this expression. So there won't be any segmentation fault in this case. Why? This AND operation, logical AND, is short circuited. Short circuited AND. This is called as, you might have studied, short circuited AND, short circuited OR. Now what will happen if temp is null, temp is equal to null? This means this is false. When false, first expression is false in short circuited AND, then it won't evaluate second expression because this is short circuited AND. When first is false, it won't evaluate. Means when it is not evaluated, there is no problem, there is no segmentation fault in that case, right? So if you write this condition first and this condition later, what will happen? There segmentation fault comes. But we are checking first with null. If null, this will be false, it will come out directly. Now when it comes out directly, pred is pointing to this node, that we know. When this is false, it will come out of this loop, it will come here. Now whether it is adjusting pointers correctly for element 20, before this logic you have created new node, its information field is given as 20. Now when it comes out of this loop, you have predecessor node's address of this node in predecessor, right? So let us see. News link you are setting. What you are doing? Pred's link. What is pred's link field? Null. So null is given to this. So this will become null always. In this case, news link is set first. Then pred's link you are setting. This field you are setting. What is given to this field? New. This node's address is given to this field. Now it won't be null. It will have this node's address. Now this works, right? So in insertion in order, first we have to see whether element to be inserted is before first. This will form special case. For all other cases, this will be done. Wherever before first is special case, for all other cases, even after the last node also, it will tackle. So this is a logic. This way you have to develop the logic, how to get predecessor node's address. Now there is another way also that I'll take, and then we will write function for this. Function for insertion in order. See, one way we have seen by giving two temporary variables. One points to predecessor node and we have to set that predecessor node's address with predecessor. That's what first. Now by using only one pointer also I can do this. Now how? We'll see. Assume this is temp. See, first case as usual. As usual means if the element to be inserted is before this first node, then we have to tackle it separately. For all other cases we will see now. Now let us say temp I want to set to predecessor node. Now if this is predecessor node's address, with which field I have to check? With this field. Assume I'm inserting element as 7. 7 I want to insert in order. Now where this temp, what for temp I am using? To store predecessor node's address. If suppose I want to insert 3, where temp should point? Temp is predecessor node's address. This temp should point to this node only and it should stop. When I want to insert 7, temp should stop here, right? If I want to insert 10, suppose, temp should point here. So that temp is used to point to predecessor node's address, right? Now in this case, if I want this to stop, suppose insertion of 3, let us say insertion of 3. 3 should be after this node, definitely. So temp I want here itself. Now how to get that, how to check when to stop this temp? Now see, compare, keep temp here and check this and this element, second element, keeping temp at predecessor, this node, check information field of next node. What is this? Element to be inserted is 3 and next node as 5. Means definitely this node should be before this only. Means temp is pointing correctly. Suppose 7 you want to insert 7. Now temp is here. What we are doing? Suppose I want to insert 7 now. Temp is here and I should compare the next node information and that information to be inserted. What is relationship? This is 5, this is 7. This information field is less than element to be inserted, right? That is greater, means that should be definitely after this. So whenever this condition will be there, move temp. Now temp will be here, right? When you are moving, temp will be here. Now check, keep temp here and check that this element with the next node's element, info field, 8 and 7. Now 8 is greater than 7. Here temp should not be moved. When we are moving temp, suppose initially this is the case for 7. When we are moving temp C, I am checking this element and this info field of next node, temp's next node's information field with this element to be inserted. How to access this element? By keeping temp here itself. Now for accessing this information field, what I should know? This node's address, right? Now where is this node's address? This node's address is here. So this node, can I write this node's address as temp link? This node's address as temp link because temp is pointing here, temp's link is pointing to this node. This node's address is here, that is temp link. So this node's address is temp link. Its information field. Now this way also you can write temp's link. This forms address of this node, its information field, its info field. If I want to access link field of this by keeping temp here, this node's address is temp link. Temp's link field, you can access that also. Now when we are moving this temp, when temp link keeping here, you are comparing this and that element. If that element, this element is less than element to be inserted. So if this is the case, then we should move temp. Temp is given temp's link. That's it. There is no need of predecessor node's address here. Now what is happening, I'll show. As already I explained, before this, that will be special case that will be tackled. Now initially, so this is while this initially temp is given first, that will be common. Now while temp's links info field, now we will check whether it stops correctly or not. See, for insertion of 1, that is special case, before this you have to tackle. Now for all other cases we'll see insertion of 7, whether it works. Temp is given here, temp's links info field, temp is here, temp's link is this node's address, its info field 5, this becomes 5, element is 7 given. Is it less? Yes. When less, it is true. When true, it will come into loop, and then temp is moved. Temp will point here. Again it will go to loop. Temp's link, keeping temp here, you are accessing 8 now. So temp link means this node's info field is 8 and 7. Whether this condition is true or false? False. Now when false, it will come out, means what we are getting in temp, that is predecessor node's address, right? So this is another way. Now we will check whether this logic works for element to be inserted as 20. For 20 also whether it works. Initially temp is at first. Temp's links info, this 5 and 20. This is 5, this element to be inserted is 20. So this is true, temp is moved, temp will point to next element. Now again it will go to condition temp's links info field 8 and 20. This is true, temp is moved, temp will be here. Again it will give temp's link 15. This is 15 less than 20. Yes, temp will be moved, temp will be here. Now what will happen? Temp link. What is temp's link? Temp is pointing here, temp's link is null. Null's info field. What will happen here also? Again, segmentation fault. Because you cannot access any field of some null node. Means it is not pointing anywhere. Which field how can you access where node is not existence? So this is problematic. So what we have to tackle here, for this case, this logic is not working. So what we are saying, temp should stop at predecessor node's address. Now when element is 20, you want to insert, that will become last node. Means temp at the most should come here at last node. Correct? So if I want to change this, when to move temp? When temp is not pointing to last node. If temp is pointing to last node, now whenever temp is moved from here to here, temp's link is given to temp becomes here, there is a problem, this condition. But before this checking of condition, there should be another condition here to come out of this loop. So instead of this, see what I should give for managing this. When temp's link is not equal to null, and what the earlier condition, temps links info field is less than element. These two conditions. Now what will happen? First condition, suppose this is the case, temp has reached here. When it goes again here, whether temps link is null, not null? No, it is null now. When it is null, this condition will become false. So it will not evaluate this condition, right? Because this is short circuited AND, that we have already seen. What is short circuited AND? If first expression is false, then it will never evaluate second expression. So this expression has problem, but this expression will not be evaluated because this becomes false. So when this becomes false, it will come out. We are getting address in temp now, predecessor node's address in temp. When it comes here, temp has stopped here. Now you can adjust the link fields. Same for 20, what we are doing, new node is created. What we are setting first, when it comes out of this loop, you are getting predecessor node's address in temp, that is for sure. So after link adjustment, first set link field of new first, news link. What always we are giving in earlier logic, what we have given, this link, this should be given to this link, predecessor node's link field. Now in this case, temps link field you are giving, right? So what is copied? Null will be copied here. Then which field we have to set? This field. This field is accessed by temps link field, and where it should point to this new. That's it. Now all other cases will be taken into consideration here, right?